Cool.
Okay. All right, so today we are going to talk about domain and range. Okay, so our little sticky tabs are coming around.
Well, there's
Okay. So you need two of one color and two of another color. So let's first off define the domain. So what is the domain?
It's the first set of elements in a function.
Okay, well thank you for reading what's on the board. Okay, so if we're looking at a mapping, it's the first set of elements in the map. Or if we're looking at a table of values, it's the first list of numbers in the table of values, yes? It is, when we're looking at a function, it is the x values of a function, okay? So this is really important when you're talking about graphing, which is what we're going to look at today. We're going to look at graphs and determine domain and range, and we're going to look at functions and determine, like equations and determine domain and range, okay? So graphically, we're looking at how far a graph stretches from left to right, which that makes sense because, let me move this way, make sure it's getting this on the screen. Left and right is our x-axis or our x values of our graph, okay? What's another name for domain? The one that Mr. Stamson has been using a lot lately? The input, yeah. So your domain is your input, okay, of your function. All right, so now let's talk about range. The range is your second set of elements. So if you're doing a mapping, it's in the second circle or oval. If you're doing a table of values, it's the second set of values or second column of values. If you're looking at a set of ordered pairs, it's the second set of ordered pair, or second number in the ordered pair, okay? So that is the y values of the function, and it's how far the graph stretches from top to bottom or up and down, okay? Okay, so when we're looking at graphs, these are really the elements that we're looking at. How far the graph is stretching left to right, how far the graph is stretching up and down. That's what your little post-its are for, okay? Is we're gonna put them on our graph, and I'm gonna use little squares up here. We're gonna put them on our graph and kind of block off where our graph is to determine what it does, okay? All right, so let's look at our first set. Make sure that's all I wanna say about that, Let's look at our first set. So we're gonna look at a bunch of different families of functions. So the first one I want you to write down on your paper is the linear functions. Okay, the linear functions. And we're going to talk about domain and range with respect to the linear functions first. Okay, and then we're going to build from there and look at the other functions. All right, so we want to look at the graphs. Which member of this family are we not seeing here? What's another line that we can draw graphically? Yeah, the vertical line, okay. So we'll talk about that when we talk about this one, the horizontal. We're looking at the x values that you can plug in and evaluate and the y values that you can therefore get out of the function, okay? So let's look at this one first, the red one. What's this graph doing? What's it doing as it goes this way? Yeah, does it keep going?
Yes.
Okay, what about this direction? Ascending, does it keep going?
Yeah.
Yeah, that's what these arrows mean here, is that my graph goes infinitely in both directions. So what does that tell you about the x values of this? They're infinite. I can plug in the biggest x value that I want to and still get a corresponding y, and the same with the y values. I can plug in any y value, okay, and get a corresponding x value. I can plug in really small. So if I can plug in anything that I want, how would I represent that? What's the domain? Not infinity. Okay, so let's talk about that. I like that if we were to write that in interval notation, Yasmin, I would start that my domain goes to, let me get red since I'm doing the red graph. Negative infinity all the way to what? Positive infinity. Okay, this is interval notation. Yes, we've talked about that. I can pick any x. Okay? What's another way to write that?
X is, or like, negative infinity, x is greater than or equal to positive.
Okay, so you could write it in inequality form like this, Kevin. Is this what you're saying?
Yeah.
Yeah. Okay. So if we were going to do set builder notation, x such that x exists from negative infinity to positive infinity, what kind of numbers are we talking about there? A whole lot of them. What kind? Think about your number
Oh,
system.
real numbers?
Yeah. How do I write real numbers?
You don't write
I. That's an imaginary number.
That's why I said you don't write I.
You don't write I. Okay, yeah, you don't write I. That's the notation for the real number system.
Well, why don't they just write normal numbers?
What do you mean write normal
Like,
numbers?
just like 5, 6, 7.
Because it's not just 5, 6, and 7. It's all the numbers in between 5, 6, and 7. All the fractions in between all of those. It's not just the whole numbers or the integers. Okay? I can pick square roots. That's part of this.
Oh.
Okay, right? I can plug in the square root of 2. It's going to give me a decimal, but I can plug it in. Okay?
So
So-
I is not between infinity and negative infinity?
I is an imaginary number. It's not in this number system. This is the real number system versus the imaginary number system.
Yeah, I just meant. Okay.
Yeah? Okay. So, do you know why it's double barred right here? You remember from Algebra 1? How many years? 2? Do you remember why it's double barred? If you read it, yeah, you did, because you learned real, rational, irrational, integers, whole, natural numbers. Yeah, okay. So this is the real number system. It's double barred because when you read it in a textbook, it's bold, okay? But when you write bold, you can't really write bold when you're writing, okay? So they double bar. I mean, I guess you could color it in really dark, but they double bar that to indicate that it's bolded, okay? Tell me about the range of that one. What kind of y values can I get? All of them. So what would I write here?
Same thing.
Either negative infinity to infinity or all real numbers. Okay? This is acceptable to me, but if you like this better, either one will work. I would like for you to be able to translate fluidly between those two, okay? Kind of like transferring between the different mapping, table of values, graph kind of deal, okay? All right, tell me, does this change when I go to the blue graph? What's different between this? Tell me this to here.
Start with infinity instead of negative infinity.
Okay. So let's address. Tell me first, Megan, what's different between this graph? How would you describe this graph?
That's a
Positive slope. How would you describe this one? Negative slope. Okay. Does it affect this?
Doesn't have
Is the domain still negative infinity to infinity? Yes. Is the range still all of those? Okay. So so Megan, your question was, well, would I just flip it over since it starts on the high end? But what's on the high end? The x's or the y's down here? The y's, okay? But here's the deal with that. We always write them in the order that they would appear on the number line, reading left to right, okay? So when we read a number line left to right, it still goes like this. Even though graphically the positive may be on this end and negative may be on that end, we still think about number line lines. So when we switch to a negative slope, it's still all real numbers. So you should that's what should be in your notes for these guys, okay? Linear function. Positive slope is all real numbers for domain and range. Negative slope is all real numbers, domain and range. Let's talk about this guy. Domain is the same. Good. Why is the domain the same? It's still moving this way, infinite, right? That's what those arrows mean. So the domain, let me get my green. The domain is still this. What changes? The range. What's the range?
2.
Okay.
Oh no.
It's x comma
0, 2 would mean that it went from 0 to 2, Colton. So let's rephrase that. What's the?
x comma 2.
It's
It's just 2.
just 2.
Yeah.
It's just 2. And Yasmin, let's talk about that. You said x. What's range? The what values? The y values, yeah. Okay. So, let's talk about a couple different ways to write this, okay? If I were to write this in interval notation, how would it look? It is. What are those? Megan says it's this.
Brackets.
Yes, brackets. Why is it brackets, Megan?
Because the only value included is
The only value included is 2. It doesn't waver from 2 the entire time. Okay, now, let me pull that up on the board a little bit higher so that you can see it. Okay, set builder notation. Y, who knows how to read this bar right here? Such that, y such that, y equals 2. Now, how could I get that from this graph? What is this the graph of? Y equals 2. Okay.
Why would you write it in builder notation?
Oh, you can write it in multiple notations, Kevin. I'm just showing you the different ones. Is that okay? Okay. Somebody tell me why. Let me get a different color. Somebody tell me why this. Let me draw my coordinate plane. Is not included.
Because the domain.
Because there's no, there's like no line.
Can you tell me the domain and range of this? Here, let me put some tick marks. What's the domain of this? 3. What's the range? All real numbers. Why is this not included when we're talking about linear functions?
Is it because it's undefined?
Because it has an undefined
Because it only
slope.
has one.
Undefined slope doesn't, no. What does it mean to be a function?
Oh, vertical.
Does this pass the vertical line test? No, it's a vertical line, okay? So, can we list the domain and range of this? Yes, the domain is what? 3. The range is all reals, but it's not a function, okay? So when I talk about the family of functions and I talk about the linear part of that, this is not part of that because it's not a function. Is everybody okay with that? Okay, here's where your little tabs come in. So give me, draw me 4 little coordinate planes. They don't have to be big, okay? We're going to talk about 2 families together because they look very similar, okay? We're going to talk about the quadratic, and we're going to talk about the absolute value. What is the quadratic? Don't draw them on your little things. Draw them on your paper. Draw them on your paper. 4 little coordinate planes on your paper. Sorry, I wasn't clear about that. Draw 4 little coordinate planes on your paper. We're going to talk about the quadratic and the absolute value function. What does a quadratic look like? Okay, so that, no, a squared plus b squared equals c squared is not a quadratic. What is that? That's Pythagorean theorem. What does it look like graphically, Kevin? What does a quadratic look like graphically? A U or a mountain? A parabola. Yeah, if we want to use real math nerd words, yes, parabola. What's an absolute value look like?
A V.
A V. Either a V or an upside down V. Okay? Alright, so let's look at the 2 different scenarios. So let's look at the quadratics first. Because I'm going to do these 2 with you, and then I want you to try the absolute values, okay? So sketch these real quick on your graph, what they look like, because these are the 2 different scenarios, right? We have the U and the mountain. And then I want you to translate that to the absolute value, because they really do the same thing, okay? So here's where your little Post-its come in, okay? Does this graph have a stopping point?
No.
It does not?
No.
Yes, it does. There is a point that graph stops and changes direction, correct?
What?
Okay, where is that point that it stops and changes direction?
It's like the first
Yeah, right here. It's
It
the,
doesn't,
oh,
it doesn't like stop, it just keeps going.
what? It doesn't stop right here?
It turns around.
It doesn't stop, it just keeps going, but it changes direction.
Okay, it changes direction. but it does not go any lower than that. Is that a better phrase?
Okay, yeah.
Yes. Okay, so if you put your post-it there, now let's figure out what's going on and how that alters what we're altering, okay? Okay? So, what does that change? What does that change? The domain or the range?
Right?
If I'm talking about how low something gets, it changes the range, okay? Because I'm reaching a point that I don't go any further down, and down is domain and range, is range, correct?
Yes.
Down is range. Is the domain affected here? Can I plug in numbers out here?
No. Yeah.
Yeah, because what does this graph continue to do? Yeah. Y'all get to see all my weirdo movements by videotaping it this way, okay? I have to watch myself. This is going to be weird. This keeps going like this. So I can continue to choose x values this way because they're eventually going to hit it up there. Same with this guy. Eventually going to hit it up there, okay? So my domain does not change. Let me grab my red. You guys told me that my range is what changes. So tell me what it is.
Is it y is greater or equal to -3?
Y is greater than or equal to -3. Do you agree with Megan?
Yeah.
I'm going to write it. Y is greater than or equal to -3.
It could be any value above -3.
It's any value above -3. So, here's where you guys make a mistake here, okay? You realize that it stops here, but guess what value do you choose instead of -3? The x. Do you write 2?
Yeah.
Okay, so make sure when you label that this is our vertex, this is 2, -3, the range is affected by that, okay? The range is affected by that. Can you write that in interval notation for me? What does that look like? Numbers bigger than -3.
So is it -3?
Bracket or parentheses? Yes.
Bracket.
Bracket. -3.
Less than? Greater than?
No, these are, remember when we're doing interval notation, it's got bracket or parentheses and a comma in there. Comma.
And then, infinity.
Infinity, because it keeps going on forever and ever in that direction. Is that right? Okay. Okay. Move your little tab. Move your little tab down to this guy. Block him off for me. And tell me which one's affected now.
The negative one?
Wait, domain or range? Sorry, let me clarify. Domain or range? The range is affected. The range is affected. I can still pick X's way out here. It's just going to take forever before I hit the graph, but I can choose them. When I'm putting this on top of a function or underneath a function, that's the range. Top and bottom is the range. If I'm putting something over here blocking off a function or over here blocking off a function, there's your domain. Does that make sense? So if I'm putting, my domain here is going to be what? All reals. Now talk to me about my range now. Jake, you want to take a stab?
In this case, you need the bracket 1 and comma -.
Okay, really close. If I'm putting that on a number line, what would come first, the 1 or the -infinity? If you're reading left to right on a number line.
This is going up and down.
Yeah, you can think of it that way too.
Parenthesis -infinity.
Perfect. Comma.
Just 1.
One.
And then bracket.
Bracket. Perfect. Remember that -infinity always goes on the left side, okay? And yeah, I get but it's going up and down kind of thought process there. But just think about numerically number lines left to right, okay? Can you write this Colton, like this.
And y is less than or greater than 1.
Y is less than what? Or equal to 1, yeah. Is everybody okay? Okay. Y'all are kind of in pairs. So y'all three, Daniel, you and Jake, and y'all three over here, I want y'all to consult each other on this one, because it's basically the same thing as that. Consult. Talk to each other. It's essentially the same thing. So can you write out the domain and the range? That's all you got. Basically the same graph, it should be instead of being you.
Yeah.
Yeah. Okay, so consult with your partner, because I'm gonna call on people to tell me what these are. And make sure that we can do both notations. Yes? I'm gonna get more specific here in a minute, but about how I want you to write them. Are we ready? Are we still thinking? Still thinking?
Yeah.
Okay, about like 30 seconds. I'm gonna count in my head. I can't do like this because then the camera goes. Are you ready? Okay. Go ahead and tell me what the domains are for both of these.
All roll.
All reals, yeah. I'm gonna go ahead and write those in. Alright. Megan, you wanna take, oh, I wrote it in the wrong spot.
You wrote that wrong.
I wrote it in the wrong spot. There we go. Alright, Meg, you wanna tackle the first one? What's the range here?
Bracket,
Uh-huh,
-3,
uh-huh.
comma, infinity, parentheses, or y is greater than or equal to negative.
Good. Good. Okay. Fix my little R right there. Okay. Daniel, you wanna tackle this one? What'd you get?
I got y is less than or equal to -2.
Good. Okay, can you do this? You need interval notation for me?
Yes. Bracket -2.
Oh.
No. Bracket.
Yeah, parentheses. Negative infinity, all the way to -2 bracket. Do you understand the difference?
Yes.
Yeah.
That's what I meant to say.
Yeah, I know y'all naturally want to do this, but it's the same as when you write here. Normally we write things like this, and that means all numbers between 2 and 4. Okay, but sometimes y'all want to mash them together when it looks like this, which is technically not right, because this says numbers greater than or equal to 2, and this says numbers greater than 4. There's overlap there. Does that make sense? So, yeah, you can, but, you know, not. We're not going to write things like that. Okay? All right, let's talk about the cubic, because here's where we start doing funky stuff for some reason. Okay? You want to sketch it real quick? The range on the last one?
Yeah.
Y is less than or equal to -2. negative infinity, negative 2? Everybody okay? Okay. Alright, so let's talk about the cubic. And here's why I want to talk about this guy, and here's why I drew them two different ways. Look at the blue one first. Can you tell me what the domain and the range is on that one?
Is it just all real numbers and all real numbers?
All real numbers and all real numbers. Kevin, can you elaborate on that?
Because it's the same thing as the parabola.
It-
Just keep going.
But
Well-
there's no point.
What?
There's like not a single
There's
point.
not a stopping point, okay? There's not a stopping point. This says to infinity this way. This says to infinity this way. So would you agree with me that the range is all real numbers? So is the debate about the domain? Okay. So,
But when it eventually,
will it eventually end?
no, I mean, it would eventually like cover all the x values.
Yeah, it eventually, even though, Megan, it's super skinny, there's not an asymptote there that's cutting it off. Does that make sense? Do you see the asymptote down here? That's the difference. This has a clear asymptote. With this cubic, remember with cubic functions, I can plug in any x and any y and get something out of them, okay? Now, what about this one?
Is it like an inequality, or like, don't you have? for
Here,
your
go ahead.
Domain, isn't it only between, no,
Okay.
that's not right.
So that's where the issue comes in with this one, okay? You guys see the arrows right here? That means it goes on forever in both directions, but this troubles you because it clearly hits a peak and it clearly hits a peak, okay? But these have a special name. These are called a relative max or a relative min, okay? It's relative, meaning that if I look just at this little section of it, yeah, it hits a max and a min, and the domain and the range would be restricted. But the arrows say that I'm going on forever and ever, okay? Is everybody okay with that? You're going to get more into relative max and relative mins in pre-calculus, okay? Go ahead. All right, I want you to try this one. Okay, can I remind you what a rational function looks like? Do you guys remember, like, algebraically what a rational function looks like? This is what you all didn't like this chapter. So f of x rational function equals some function over another. Remember, like where sometimes we factored and canceled stuff out, and it would be like x squared minus 4 on the top, and then 1 minus 2x on the bottom. Remember doing that? Where we had to find vertical and horizontal asymptotes and slant asymptotes and all that kind of stuff? Yeah, you remember that? Okay, so that's what I mean when I say rational function, is there's a function on top and the bottom. I want you to discuss with your little crew the domain and the range of both of these functions. This one, the asymptotes are very clearly labeled. This one, there are asymptotes that are there, but they are not labeled, okay? Did you write it?
Or is it one and negative?
Oh, okay. Let me look at it, and swing by before you, are you planning to leave? Okay, swing by and I'll chance to look at this. Do you need me to write you a note back to this? Yeah, I'll look at it. And just swing by, okay? Yeah. Off of this. I have to take it to the office. I have to swear it, Mr. Rose, okay? Initial the back. Hey, how we doing? We're doing? We're doing all right? Okay, so talk to me. I'm gonna move this up a little bit. Talk to me about it, Colton. I'm doing all right. Talk to me about red.
So your asymptotes are like your x and your y.
Yeah, your x and your y what?
Axes.
Axes, yeah. So there's my asymptotes if I were to draw them in, right? Okay, so talk to me about how that restricts the domain and the range.
That's what we were kind of going through.
Okay, so what's your thought process?
It would be like less than 0 and greater than 0.
So rephrase that for me so it's a little bit easier to understand. If it's less than 0 and or greater than 0, what can it?
It's not 0.
It's not 0. Okay, so can we write the domain? Let's write a couple different ways. X such that x cannot be 0. Everybody okay with that one? Okay. So can you write that in interval notation for me?
Parentheses,
Okay.
negative infinity.
Yes.
Comma 0.
Yes.
Parentheses.
Uh-huh.
Comma parentheses.
No, wait,
Union.
Union.
Or
Union, yeah.
0, comma infinity.
Perfect.
I got it.
Did you get that? Kevin got the union. He contributed that. Now, tell me what's different from here to here. From here to here.
It's y.
It's y, okay? Y'all understand that's the only difference? The y can go to positive infinity to negative infinity. It just can't touch y equals 0 right here, okay? So I'm not gonna write it like this. I'm just gonna write it like this. Now, here's what I'm gonna tell you, because I know some of you are gonna prefer one way of writing it over others. You need to be fluid in all the different ways, so maybe start off doing some like this and then switch and try to go to here, and you understand what I'm saying? Okay, so talk to me about this one.
It can be
Silence.
anything but negative 2 and 1.
Okay, so Sam, you're talking about domain, yes?
On domain.
Okay, so the domain. So tell me like this, x such that x what?
Does not equal negative 2, comma 1.
Everybody okay with that? Talk to me about the range.
It cannot be negative 1.
Okay, it says it cannot be negative 1, right? But does the graph touch it? Look.
Oh, yeah.
Okay, so let's talk about vertical or horizontal asymptotes just a little bit, okay? Horizontal asymptotes apply as the graphs approach negative infinity and positive infinity. So sometimes the graph will cross them close to 0, okay? So this looks like an asymptote right here, but my close to 0 actually crosses that line. So then what's the range now? Is negative 1 a restriction? No, because it crosses over it. So it's included. So tell me all reals. There you go.
What?
Did you miss my explanation?
No, I didn't. It just.
Okay.
Wow.
Now y'all are going to get into this way more next year when you talk about limits. It's going to be exciting. Yes, the limit does not exist for a mean girl. Okay. All right. I want you to try this one with your little partner group, and then I want to talk about the step function. What's quartic mean?
4.
Degree 4. Okay. Degree 4. Hey. Leading coefficient, positive or negative?
Positive.
Why?
Because it goes up.
At the top.
Up and up.
Had a 50-50 chance.
Well, yes, you did have a 50-50 chance of getting that right, but it is positive leading coefficient because my endpoints are going in the positive direction. Okay, go. Domain and range. Tell me what it is. Actually, why don't you try this by yourself? Sure you can.
Took your arms out of your sleeves. Good.
Where's Emma today? On the serve. Remarks to John.
Her surly remarks to John.
Oh, what? Me and John?
No, I went John.
Emma and John.
Actually,
I miss John.
I went
Yeah, that was it.
All right, have we answered this? John's gonna watch this video, and y'all are gonna talk about how much you miss him, and he's gonna be like, "But it was
John,
on
I
here."
love you.
Don't read too much into it.
All right, hey, so talk to me about this one. What previous graph that we worked on can you kind of compare this one to?
Quadratic.
The quadratic. Why?
Because it has a stopping at the low point.
Yes, it has a low point, okay? So, can we draw a comparison there? We've got, what kind of degree is the quadratic? Degree what? Quadratic.
2.
2. What's this one? 4. So what can we conclude about even degreed polynomials?
How did you know it was 4?
They're going to have a stopping point. So either they're going to reach a low or they're going to reach a high, okay? What does that restrict, the domain or the range? The range, okay? The range. Okay, so since you just told me it restricts the range, what's the domain of this function?
All real numbers.
All real numbers. All right. Kevin,
What?
what's the range?
Well, it's negative.
The range is not -3. That would be a horizontal line through -3. Be more specific.
Well,
Y has to be what?
y has to be greater than.
Or equal to. Yeah, there you go. Greater than or equal to -3. Do you have a question, Sam?
No.
Okay. Who wants to attempt? Yasmin, can you do interval notation for me here? Go ahead and start telling me. What you thinking? Okay, but where's this going? Greater than or equal to? It's going from -3 that direction.
Okay, so positive infinity. Oh no, -3.
-3 bracket or parentheses.
It's bracket.
Bracket.
And then
That just totally does not look like a comma. Let me try that again. -3 comma infinity parentheses. Does that make sense? Okay. All right.
Why,
No.
would the range be 3, 6, 9, 12?
Are you on this one? I think Megan has a question on this one, and then yes, you were right.
no, I don't. It's okay.
You're okay?
I was just thinking.
Okay, so Nicole's already started looking at the step function because she thinks it's interesting, which it's an interesting scenario. You remember my Dollywood example yesterday. Okay, so tell me about Nicole. What Nicole just said was the range is what?
3, 6, 9, 12.
3, 6, 9, and 12. Do y'all see that? There are no other Y's that I can choose, okay? So, well, let me get the right color. All right, so 3, 6, 9, 12. What's the domain?
Is it
R was
between,
6, 8.
wait, is it between,
It's like 2, it's greater than or equal to 2,
It's greater than or equal to 2.
less than 4.
Yeah, but look, 4 is not included here, but it is here.
it hits every point,
See?
isn't it?
It hits every point. Good. It hits every point because everywhere we think there's a hole, there's a matching
So
closed circle. Yes, except
All
for
the way to,
20.
20. Okay, so can you write that like this?
so it's parentheses,
Bracket.
a bracket,
Bracket
2,
2, comma, 20, parentheses.
Oh, parentheses. Why is? Oh, just kidding. I know why.
You know why?
Yeah.
I'm gonna draw it even though you say you know why, so that the people watching later can know why too.
Hi, John. I love you.
Does that make sense? Are you okay with that?
Can you write it in the other form as well? I'm just
Sure. Sure. Like this.
Yeah.
Okay. So can you do it? Let me draw a little arrow. X such that X is between 2 and 20, including 2 but not 20.
So would it be, well, let me write it down. Just 2
2
less than or equal to
less than or equal to?
y.
Well, not Y.
Oh, my bad. X
X.
less than 1.
Perfect. Good, Nicole. How we feel? Okay. I want to do 3 more graphs with you, and I actually want you to look at these 3 graphs real quick. Okay, I want you to look at these 3 graphs and see what you can come up with. Okay, and then we're gonna translate to equations, and I have 2 slides of equations and we're done, okay? So try these with your group, okay? All right, go. Write down the functions. Write down the functions.
I don't know how to
Function
write a
with a
function
whole. Whole,
Well, yeah, but like,
just write
but like, what is that, what does the equation look like?
it could be 2 different things. It could be a rational expression or rational equation, because if rationals have something that cancels on the top and the bottom, that creates a hole in the graph. Okay? Or, like if you had this, Kevin, if you had this, I'm not saying that this is gonna be that equation, but something like this, and these canceled out, that creates a hole at 2 on the graph.
Why?
Because technically I could plug into here, but if I plug into here, what happens in the denominator? You see what I'm saying?
Yeah.
Okay, so that's something that can create a hole. You can also have a hole with a piecewise function. So this could be one function to that point, and this could be one function to this point, and there's no equal to at that point. Does that make sense? All right, y'all try these other ones.
What was the answer?
Oh, I'm not going over it. He was just asking what made a hole. I was just clarifying. What made a hole? I'll come here.
No, it has to do with the remote that's not right.
John, I love you.
No, it has to do with the remote that,
Yeah.
yeah.
Yeah. That's why I've been taking it off if I walk back there, so it doesn't track me all the way back to the back of the room.
Feel the remote.
Okay. Okay, let's talk about this one. Anybody want to attempt the first one?
No.
No, you won't.
No?
Do I? I'll try it.
Okay, so talk to me about the top, the first one, Megan, the domain.
The domain is all, it's not all real numbers.
It's not all real numbers, so
Is
it's
that
not
a
included.
union? Because is it negative infinity all the way to 1, and then union 1 all the way to infinity?
Okay, that's one way to write it. Okay, so Megan said this. Does everybody understand that notation for that? Okay, can you tell me another way to write it? With the squirrely brackets, x such that,
Such that x, no, infinity, negative infinity.
yeah, x cannot equal 1. Good, Nicole. Does that make sense, Megan? Does that make sense?
Yes.
X can equal 1. So when you're writing something in right here, you want it to be like an inequality or and does not equal to sign in there. So like what we did with yours earlier, I could write -2 less than equal x less than 20. Okay, that's what needs to go in here. Okay. All right, who wants to tackle the range? Stopping point on this one? Is there a stopping point?
No,
Is it all real numbers?
no, it's not.
It doesn't go above that.
No.
It doesn't go
No.
above
Oh,
this
yeah,
number,
yeah,
right?
It was either
Yeah.
three.
So the highest it can get is 3. Do you think that it goes below here?
Yes. No.
No, it looks like to me that this is another asymptote here, right? So, what would that be?
Well, how do you know something?
Another union set?
Okay, so they probably should have denoted that this was an asymptote. I probably should have denoted that that was an asymptote.
Is it because it's like a bell-shaped curve?
Yeah, it's kind of a bell-shaped curve. It's never gonna get underneath that the x-axis. So now, do you want to take a
No,
stab at it?
no, just how would you know if it has an asymptote? Like, if you look at a parabola, it looks like you could maybe put 2 asymptotes on either side.
Well, but you know that it doesn't do that.
Well, you didn't know that it doesn't do that.
Well,
there.
technically, I should have drawn in the asymptote, like I did on these two.
Okay.
Okay, so now that the asymptote's there, tell me what the range is.
Anything between 0 and negative 3.
Anything between
Oh,
0 and
Positive.
Or sorry,
positive 3,
3,
yes.
yeah.
Does it include
No, it does not.
either one of those?
No.
So y such as y,
Okay, so you're doing it like this, Colton?
yeah, y does not equal.
What did we say the range was? Anywhere from 0 to 3. So write that for me. 0,
So
less than, y,
is
less than 3. Or, if we're going to write an interval notation,
0.3.
everybody okay? Okay, can you do this one for me?
What?
Do the blue one. Here, let me ask this question. Which is all real numbers, the domain of the range? I heard domain and I heard range.
It's one of those two, I know that.
If your domain should have a horizontal
Boom. Y'all say that louder, Nicole, so that hopefully the video will pick it up too.
domain is all real numbers because there's a horizontal asymptote.
There's a horizontal asymptote right here. This cuts my y's off, Colton, from going underneath that line, okay? So the domain is all reals. So what's the range now? Y is greater than -4, okay? So I'm writing this in all different forms. Can you do this in interval notation?
Y is.
No, interval notation like this, Kevin.
Oh.
Bracket?
Bracket?
No.
No.
Parentheses.
Parentheses.
-4,
Uh-huh.
comma, infinity parentheses.
Everybody okay? Yeah. All right, let's do this last one. Hey, we know what this looks like, right? Algebraically, or like an equation. Exponential. What's this one? Y equals log base A of X, and then transformed, yes?
Is this one like a
Okay, so which one's affected here, domain or range?
domain?
Okay, I think you're answering which one is all real numbers. Are you answering which one is all real numbers? Yasmin, which one's all real numbers?
Range.
The range, okay? The range is all real numbers here. Okay? Because do you see where the x values stop? Where do they stop? At 2. Okay, so write that for me domain-wise.
Y.
No, domain's not y. X, such that
X is greater than,
greater than 2, because look, here's 2, where am I here? 3, greater than, yes? Okay, interval notation. Oops. Interval notation.
2.
Uh-huh. Bracket or parentheses?
Bracket. No parentheses.
Parentheses, it never touches that asymptote, remember? 2 to
At infinity.
infinity. Yes?
What's the range for
The range for the function with the hole in it. From here to here. Doesn't touch 0. Doesn't ever reach 3. Looks like it does, but it doesn't ever hit there. Okay? Alright, here's what I'm going to do. I'm going to put up some equations, and I want you to discuss them with your partner and decide what the domain is. Okay? Alright, just the domain. We're going to talk about the range, okay? Let's think about graphically what they look like, and some of these we've gone over. Okay? Alright, go. Talk. So go back and look, because we've hit several of these on here.
Isn't that just a line?
This is a line. What's this one?
It's a quadratic.
Quadratic. What's this one?
A cubic.
A cubic. We haven't done this one, so you need to think about what this graph looks like. What about this one? Exponential we just did. start calling on people and come up here and write.
Oh,
So y'all get to be on the video too.
No.
I'm gonna stand right here so it'll get y'all. Alright, who wants to do the first one?
Who will do it?
Sam? 2. Who wants to do the second one? The quadratic. Domain of the quadratic? We did that one. Flip back and look. We did domain of the quadratic. Yeah. Yeah. Are there any lines that have a domain restriction
No.
in the linear family? No. Okay? In the
Well-
linear functions family, there are none that have domain restrictions. What's the one that has the range restriction?
A straight line.
The horizontal line, yes.
Wait,
uh-huh.
so you mean, if it's, wait, a horizontal line has a domain restriction?
Has a range restriction.
So, doesn't a vertical line have a domain?
Yes, but it's not a function. Remember we talked about that?
Alright.
Because it doesn't matter. We're just talking about functions here. You want to do this one?
We're still number 2 then.
All right. Nicole's going to answer too.
Hopefully I did it right, but
I hope so too. Yeah. Do quadratics have a domain restriction? No, I can plug any x I want to in there. Where's the restriction in a quadratic? The range, okay? Remember, a quadratic either has a max or it has a min, and that affects the range, yes? What about this one? What's this graph look like?
So it's like the V.
So it's the,
Yeah, okay, so it can look like the chair, or it can do a real deep curve. Remember, we talked about that too. Is there a domain restriction?
No.
No. Is there a range restriction?
No.
No. The cubic is the one that there's neither one. Let's generalize that. With this one, we said all even degreed functions don't have a domain restriction, but will have a range restriction, right? Because they're either going to hit a peak or a valley. What about this one? No domain restriction, no range restriction. So tell me about if I went to a 5th or a 7th or a 9th root. Is that same thing? Is that right understanding?
Yes.
Okay, let's talk about, what does this look like? Who remembers?
It's a step. See,
No, that is this, Colton.
What's that?
What's this?
it's a sideways C, it's an S.
It's an S, yeah. You remember when we drew these? And they looked like this?
So you kind of stretch it and move it to the side.
wait, will odd root functions ever have a restriction?
Okay, so let's answer that question.
Well, I should say normal ones, not ones with poles in them.
Yes. Like your traditional odd root function.
No, if
Does
was
it have
the
a
same
domain?
range.
Can I take, the question with domain is, can I plug in, what x values can I plug in, right? Can I plug negatives into a cube root?
Yes.
Can I take the cube root? Yeah, I can take the cube root of negative 27. What is it?
3.
Negative 3, okay? I can take the cube root of negatives, okay? So, generalizing, odd root functions, the domain is all reals. Okay, talk to me about this one. What kind of x's can I plug in there? Because that's what domain is asking. Is there a domain restriction on exponential functions?
No.
No. Where's the restriction?
Never.
The range. It's got a horizontal asymptote. Okay. So the domain has no restrictions. All right. Let's talk about these guys. I want to go through these pretty quickly. Let's go through these pretty quickly. Let's talk about rational functions. Actually, let's do the even root one first. Let's do the even root one first. We just talked about how odd roots, we can plug whatever numbers we want to in. What about evens? I can't have a negative. I can plug in negatives, Megan. I just can't have a negative right here. Right? Once I plug in a number, I can't get negative. Okay? So tell me how I could figure that out. This has to be what? Or, can it be 0? Yes. So, for this guy, 3x minus 21 has to be greater than or equal to 0. So now tell me, solve it. What's x have to be bigger than? Greater than or equal to 7. So my domain restriction is that x has to be greater than or equal to 7. Is everybody okay with that? Yeah? Who remembers how to do this?
If you shorten the word to simplify the roots, and you have to take the 2 off the board.
No, I can't do that. I understand what you're saying. You're trying to take the fourth root of everything in there. Can't do that. Can't split it up. Is the restriction any different? Does this what does this have to be? Bigger than or equal to 0, right? It's the same restriction as this one, because this is degree 2, this is the half degree, this is the fourth degree, fourth root, okay? So, let's figure that out. Set this equal to 0. I don't have enough space. Let's see if I can move some stuff down.
Square root of
Oh, don't do that. Don't do silly mess. If I set this equal to 0, how do I solve, or greater than or equal to 0? Remember? How do I solve this?
3 and 5.
It's 3 and 5. What method are you using, Colton? You're using AC method. Yeah, factor it. What's it factor into, Colton?
Positive, or negative 5 and positive 3.
Negative 5 and positive 3. So what are my x values? 5 and negative 3. Oh, do you remember what to do with those?
You have to plug them back in and make sure it's greater than or equal to 0.
Yeah, I gotta figure out where it's greater than or equal to 0. Remember we did this? And we picked numbers? Oh yeah. Ah, we're dying.
Wait, why
Okay.
wouldn't it be 5 since 5 is greater than 0?
Okay, but it can be equal to 5. Okay, but what we're trying to figure out is what numbers can I plug in to make this bigger than or equal to 0. Okay, so if I plug in 5, Nicole, I get the equal to 0 part, and if I plug in negative 3, I get the equal to 0 part. Now where's the greater than? Do you understand what I'm saying? These two numbers give me the equal to 0. I need to figure out where the greater than is. Okay, so hey, do this for me. Plug in 0 real quick, because that's an easy one. If this one's not it, then my answer is here and here, right? Do we remember this?
Yeah.
Yeah? Okay, so plug in 0. What do you get?
Negative 2.
Negative 15. Is that bigger than or equal to 0?
No.
No, so where's my shade go?
Greater than 5.
Greater than 5. Closed or open dot?
Close.
Closed, because it's equal to. Close because it's equal to. Oh man. We're taking it way back. Yeah? So now tell me what the domain is.
Is it negative? Oh no.
Negative infinity, or close.
So if we say, if we're going to write it like this, y has to be what? Less than or equal to negative 3, or what? Greater than or equal to 5. Okay, now do the interval, Yasmin, you were trying to do.
Negative infinity.
Negative infinity to negative
Negative 3.
bracket
Unity.
union.
Union, yeah. 5. Comma. Infinity.
Okay.
So would the answer for what the domain would be is x such as x?
Oh, yeah, x. Sorry, I put a y. I'm so used to doing domain first and range second. Sorry about that. Let me not confuse you. Alright, x is less than or equal to, or x is greater than or equal to. There you go. Fix it.
2 questions. One for
Yes.
unit functions. So do the y's have any or ranges have any do the ranges have restrictions for even root functions?
Okay, so you tell me. So range, we're thinking about the same types of numbers, Nicole, negative, 0, and positive, right? Can I take the square root or the fourth root of something and get a negative number? No. So there's your range restriction. Y is bigger than 0. Or equal to 0. It can be 0, okay? Alright, I feel like you're dying on me a little bit. Are you dying? You're kind of acting like you're dying. Okay, here's what I want to do. I want to practice this, but I want to tell you really quickly how to do these two. When I have a fraction, what's the restriction?
Range. Is that right? Is nothing near y or near?
What can, here, well, I'm asking about domain. The question is, what can I plug in for x?
Oh, it's whatever.
Can I plug in all real numbers? So, Colton, what happens if I plug 2 in right here? I get 0 where? in the denominator. Can I have 0 in the denominator of a fraction? No. So when you see a fraction, you're gonna set the denominator and say that it cannot equal 0, and then figure out what makes it equal 0. And there's your domain restriction. Okay? That's also where your asymptotes come from. Remember when we talked about this? Okay, those asymptotes can't be those numbers. So this would be, so x cannot be 0 or -3. Okay? What about this one?
X can't be plus or minus 2.
Plus or minus 2. Good. Yeah. Okay. Alright. I'm going to hit pause right here. There was the only ones I didn't get to go over were how to do domain and range from mappings. I think we know that, yes? What's the domain here? These numbers. What's the range? Those numbers. What's the domain here?
Those numbers.
What those numbers, the x values, what's the range? The y values, what's the domain here?
Those numbers.
This, the first column, the range is the second. I think we can do that, yes? Okay. All right, let me get your worksheet.
Worksheet.
You